recording. Awesome. All right. So, chapter 1. So, as we're going to see, chapter 1 is basically just an introduction to statistics. There's a couple of vocabulary words that we're going to have to know from chapter 1 that we're going to continue to use throughout the semester. And once we get to those, I'll make sure that you're well aware of which ones that there are, which ones those are. There are some definitions in chapter 1 that aren't super important to remember for the entire semester, but some of them are pretty important. So let's first start off. So here, the first definition in the book is simply just that of a population. And a population is simply just any specific collection of objects or interests. A population, the best way to think about a population is this. Anything that you're considering has to be included in your population. So if you're saying this, right? If you're saying, hey, I want to figure out what the average height is of all students at UNCC, maybe for some reason you're curious about that, then all students at UNCC would be your population. If you said, hey, I was interested in what the average height is of all people in North Carolina, then everybody in North Carolina would be part of your population, right? If you said, I'm interested in figuring out what the average height is of everybody in this classroom, then this classroom would be your population. So a population doesn't necessarily have to be big. It doesn't necessarily have to be small. It just has to include everything that you're interested in, right? Everybody good with what a population is so far? Now, if you take a part of that population, then what you're doing is you're taking a sample. So any subset or subcollection of a population is a sample. So again, if you said, hey, I'm interested in figuring out what the average height is of all students at UNCC, then that would be your population. But chances are, if you wanted to figure out what the average height is of all students at UNCC, what would you do? Right? Like if I said, hey, I just won the Powerball. I'm sitting on about $100 million of extra cash laying around. And one of the things that I was always wondering is, what's the average height of all students at UNCC? Hey, I got a lot of money. I can pay somebody to do that. And now let's say you come to me and you say, hey, I want to answer that question for you. Pay me $1 million, right? And I would say, okay, cool. How would you go and figure out what the average height is of all students at UNCC? You could ask a survey, right? You could simply just go on and figure out everybody's email address or something, send everybody a survey, and say, hey, tell me what your average or what your height is, and then take an average of that. What would be a different way that you could figure out what everybody's average height is? The average height of everybody at UNCC. You could take a sample, right? So one of the things that you could do is this, right? You could say, hey, Michael said he's going to pay me $1 million if I figure out what the average height is of everybody at UNCC. Well, if I get $1 million, one of the things that you could do is you could go to Lowe's and buy like a $3 tape measure, and you could literally walk up to every single student at UNCC and be like, hey, sorry, I know this is awkward, but I need to figure out your height, right? And you could literally go around to every single person and record the height of every single person, and then take the average of all those heights, and then you would have the average height of everybody at UNCC. Or you could send out a survey or what have you. Well, one of the things that you could also do is you could say this. If you knew the heights of, say, 1,000 people at UNCC, and you took the average of the height of those 1,000 people, chances are you're going to be really darn close to what the average height is of everybody at UNCC, right? You might be off by a 16th of an inch or something like that, but you're going to be really, really darn close, right? Same thing if you did 500 people, or if you maybe did maybe 100 people, you might still be pretty close. But what you're doing here is you're simply just taking a sample. You're taking some subset or some sub-collection of the population in order to answer that question of what the average height is of everybody at UNCC. Right? Everybody good with what a sample is? But let's say here that you wanted to go and you wanted to take a sample. And let's say there's currently approximately 30,000 students at UNCC. What happens if you didn't just take 1,000 people, What happens if in your sample you literally took all 30,000 people? Well, then what you're doing is your sample is basically the same thing as your population, and that's what we call a census. Whenever your sample is the same thing as your population, when everything in your population is also included in your sample, and that's what we call a census. Everybody good with what a population, sample, and census are? All right. The census one is not super important for you guys to remember for the material that we're going to cover later in the semester, but you should have an idea of what a population and a sample is. Any questions about those? All right. Then let's go on to our next two definitions, that of a parameter and of a statistic. A parameter is some number that summarizes some characteristic about the population. And a statistic is a number that summarizes a characteristic about a sample. So, let's go back to the example of you want to figure out what the average height is of all students at UNCC. Well, let's say that you actually took that tape measure and you literally went around and you measured the height of every single person on campus at UNCC. And you took the average of all of their heights, right? So literally 30,000 people, and you took the average of 30,000. Then that would be a number that summarizes some characteristic of your population, right? The height. So that number then would be a parameter. If, however, you said, hey, I'm not going to measure all 30,000 people, I'm only going to measure maybe 1,000 people, and then after I measure those 1,000 people, I'm going to take the average of those 1,000 numbers, well, then what you did was you took a sample, so the average height of those 1,000 people, that's going to become your statistic. Right, is everybody good with that? Now, there's a couple important things about parameters and statistics. Parameters are this. For this semester, especially in this class, parameters are always going to be represented by Greek symbols. So, if you see a Greek symbol, you know that it's a parameter. And if you're looking for a parameter, you know you're going to be looking for a Greek symbol, right? It goes both ways. Statistics are not represented by Greek symbols. So therefore, just like I said before, if you see a Greek symbol, you know that it cannot be a statistic. It has to be a parameter. Is everybody good with that? So, as we go through the semester, it's gonna say, hey, calculate out the average of the population. And then it's gonna say, it's gonna give you answer choices, right? Like I said, a lot of the stuff this semester is gonna be multiple choice. So you're going to see an answer choice where it's going to be Greek symbol is equal to something. Greek symbol is equal to something. Not a Greek symbol is equal to something else. You know that the answer choice that's not the Greek symbol and is equal to something cannot be the answer to a question that's asking you to look for a parameter. Right? Is everybody good with that? All right. Then here, statistics, descriptive statistics, and inferential statistics. The main two branches of statistics are descriptive statistics and inferential statistics. We're going to spend a little bit more than half of this class going over descriptive statistics and a little bit less than half of this class going over inferential statistics. Both of these branches in statistics are heavily used in the real world, right? Because anything that has some kind of data associated with it, chances are somebody's trying to do some kind of statistical analysis of that data. Descriptive statistics is simply just like it sounds, right? It's trying to describe what the data looks like. So imagine this, right? Imagine that you have some set of information, and data is simply just nothing more than information, right? Let's say you have some list of information, and this list contains hundreds of thousands of different individual observations for something. Maybe it's home prices in Charlotte, but it's not just the home prices in Charlotte. It's also how many bedrooms that house has, how many square feet that house has, how many bathrooms, and so on and so forth. And let's say you have that for every single house in Charlotte, right? And somebody gave you all this data, and you just have this huge, long list of stuff. Well, if you just look at pages and pages and pages of numbers, chances are it's not going to make heads or tails to you, right? You're going to have absolutely no idea maybe what the average home price is and so on and so forth. Descriptive statistics describes the data. So in descriptive statistics, we're going to find out like what the average home price is, what the average number of rooms are, what the average square feet are. So that if you tell somebody, hey, one city has an average home price of $250,000, and one city has an average home price of $450,000, you get an idea about what those communities look like. Right? Does that make sense? So that's describing something to you. That's descriptive statistics. Inferential statistics, on the other hand, is where you're trying to say, hey, based off of something that I know, can I infer or make some kind of reasonable conclusion about something that I don't know? Right? For example, if I say, hey, for every single Monday for the entire year so far, from January 1st until today, it always rained. Because that's what it does on Mondays, right? Like Mondays, like for some reasons kind of suck, so it rains every single Monday, right? And I told you, hey, without going outside today, I'm telling you today's a Monday, right? You would make some kind of reasonable conclusion that, well, it's probably raining outside, or it's going to rain outside, right? That's inferential statistics, where based off of some stuff that you know, you can make some kind of inference or some kind of reasonable guess about something that you're going to see, right? All right, so that's a brief, not quite, definitely not comprehensive view or just an analogy about these two things. Is everybody good with these basic definitions? So what we're going to do throughout this semester, I don't know about all of you, but I'm a very visual learner. Who in here is a visual learner? All right, quite a few of you too. Cool. So basically, all this stuff that we have right here in words, I like to put it in a picture, and the picture looks something like this, right? We're always going to start off our discussion with some kind of population. And as we said, this population has to contain everything that we're interested in. If we go back to the analogy of all students at UNCC, then here in this awesome visual, we have all students at UNCC. And I'm just going to assume here that, I don't know how many people I drew so far, but here we have all students at UNCC, right? My Picasso-like depiction of what all students at UNCC would look like. If I asked you what the average height is of all students at UNCC, what we already said is that we could take some sample of this population. So maybe we would take something like these three people right here, and we would include these three people in our sample. And here we have this. Well, what we're trying to figure out is the average height. Just as an example, right? The average height of everybody at UNCC. That's what we're trying to figure out. And I know that I have atrocious handwriting, so if I ever write something on here that you can't read, please just let me know. But we know that if we're trying to figure out the average height of everybody at UNCC, we're not going to go and measure out everybody's height. We're going to take some sample, and then what we're going to do is we're going to calculate out the average height in the sample. So we don't know this over here, the average height of everybody at UNCC. But if we take a sample of people and we calculate out this average height, well, then we definitely know this. So this right here, this number, this is going to be descriptive statistics. And once we use this number, we can make some kind of statement about what the average height is of everybody at UNCC. And this right here is inferential statistics. Right, is everybody good with this so far? It's basically just a picture summarizing those definitions that we had above. Then also, since this right here is a number that we're calculating out from a sample, we now know a new vocabulary word for this. And what's the vocabulary word for that? That's a statistic. Good. And this right here, this number is summarizing a characteristic of our population. So we also know a new vocabulary word for that. And what's the vocabulary word for that? Parameter. Good. Awesome. All right. Is everybody good with population and sample, parameter and statistic, and descriptive statistics and inferential statistics? Everybody good with this? Can I move this away? All right. Then let's go on to the next page. All right, the next definitions that we're going to go over are that for qualitative data and quantitative data. Real quick first, just about data. I briefly mentioned what data is before. But whenever I first started taking statistics, I kept hearing this word data, and I wasn't sure for like the longest time exactly what data is. So data is simply just a list of information, right? So if you create a shopping list, like what you want to buy from the grocery store, technically that's your shopping data, right? If you create a list of the classes that you want to take next semester or the grades that you've gotten in the past, and that would technically be your course data.
Did not pronounce the data. I've been saying data my whole life.
Yeah, I mean, however you pronounce, right? Like, it could be data, it could be data. I know that different regions of the U.S. or even the different regions of the world pronounce it differently. Maybe I'll alternate back and forth, right? You know, throw a little spice into this course by saying data different ways. No, not sufficient spice.
Say it differently in like the same sentence.
Oh, there you go. Yeah, I'm gonna have to think about that one, right? Like, see if I can actually work that one out. That's good. So let's try to talk about qualitative data and qualitative data. Yeah, nailed it. All right, cool. All right. First off, let's talk about qualitative versus quantitative. Qualitative data is simply just data or information that is not best described by some number, right? Can you think of examples of information that is not best described by a number? Eye color. Good. What else? What else besides eye color? Maybe worst basketball team on the planet, right? Right, there it is, right? So we'll say, how about we'll go the opposite direction? We'll say favorite basketball team. So the worst team would obviously then be Duke.
It seemed like a really simple question, but it's actually like really hard to think of. Like just to try to think.
So if I asked you to describe something, and you wouldn't say a number, what could you describe about yourself, about me, about anything?
Like how lazy someone is.
So you could say, hey, like this person is lazy, motivated, or whatever, right? So let's say
Features, like characteristics and features.
yeah, characteristics and features. features, right? Let's say that we were trying to meet and we had never met before, right? And maybe we're like, I don't know, I sold something on Craigslist, right? And I'm like, I'll meet you at the Walmart parking lot, right? And now you go to the Walmart parking lot, and like, Walmart is clearly a great place to hang out, right? So there's a lot of people there, right? And you're just like, all right, now who am I looking for? I would say something about myself that you could pick me out of a group, right? So it would be something like gender. It could be something like hair color, eye color. It could be demographics. But we could also have favorite team. What else could you describe about yourself or something else that you're not using? Preferences, right? Like, what is this? How is this food? It could be savory or spicy, right? All these different kinds of things where you wouldn't necessarily use a number. If I came to you and I said, hey, what's your favorite sports team? And you go, 3, right? That doesn't make any sense, right? Like, you would probably turn around quickly and walk away from a person who said that to you, right? So that would be an example of qualitative data. What about quantitative data? Quantitative data is information that is best described by numbers. So what would be an example of quantitative data? Salaries, good one. Good. What else? Price, what do you mean with population?
Like population of Charlotte and Carolina.
Oh, okay, like population size, good. You could also have age, maybe number of siblings. You guys get the gist? Let's add a few more over here for qualitative data. We have eye color. You could maybe have gender, maybe favorite movie, and I'll also add in hometown. Hometown. These are all examples of qualitative data. Everybody get the gist between quantitative data and qualitative data? All right. So now let's talk a little bit about the presentation of data. And we're going to go over the definition of frequency, the definition of data frequency table, and that of relative frequency. Frequency is the statistical meaning behind frequency is exactly what you would imagine frequency would mean even just in common everyday English. And it's simply just how often something occurs. Here in statistics, it's just how often a value, any value x, appears in your data set or in your list of information. So how often something occurs. Then your data frequency table is a table listing each distinct value of x and also the frequency with which it happens, which is f. And then a relative frequency table is slightly different than that. It just asks of a class of measurements. We're looking at the proportion of all measurements that make up, that are contained in that class. So let's try to look at frequency, data frequency, make a data frequency table, and also calculate out the relative frequency using this data set right here. So let's start off with this. Let's start off just with frequency. If I asked you what is the frequency of the number 5, you would say what? 4, right? Because it happens 4 times. If I asked you what the frequency is of the number 11, you would say what? 3. You guys get the gist behind frequency? Just count how many times that it happens, right? So, yeah, just how many times that a value x, any value x, I'm just giving you guys now individual values of x, like 5 and 11 and 3. However many times that value occurs, that's going to be the frequency of it. So, that's frequency. Now, if we wanted to put that in a table, it would look something like this. We're going to have the value x, whatever value x that we have, and then we're also going to record the frequency, little f, with which that value occurs. So the first thing that we want to do is we want to list every possible value that we can have of x. So what possible values do we have of x? Well, we definitely have a 2 So 2 could be a value that we have for x. We also have the number 3, so 3 is going to be a possible value of x. What other possible values of x do we have? 5. What else? 8. 11. Anything else? Cool. So now we listed the possible values of x, and now we need to also record the frequency with which those values occur. What's the frequency of the number 2? Frequency of the number 3? Frequency of the number 5? Okay, you guys already told me 4.
Is that kind of just like a stem and leaf plot?
No, it's not a stem and leaf plot.
What kind of similar?
No, it's actually not similar. It's actually very different from a stem and leaf plot. We're going to go over a stem and leaf plot here in a couple minutes. This is the data frequency table, and you're just saying how often these x values occur, which is different than the stem and leaf, but we'll see the differences here in a couple minutes. So let's finish off this. We said that 8 occurs with the frequency of 2, and 11 occurs how many times? And bam! You have a data frequency table. Everybody good with the data frequency table? If the first exam were completely comprised of making these, would you guys feel confident about taking that exam? You'd be like, heck yeah, right? That would be a good exam. All right, cool. All right, so then we talked about frequency. We just made our data frequency table. So let's talk about the relative frequency. Let's say that I asked you, what is the relative frequency, say, of the number 5. If you want to figure out the relative frequency of the number 5, then according to our definition of what the relative frequency is, the relative frequency is the proportion of all of our measurements, and here, these numbers right here are all of our measurements, right? This whole list of data right here are all of our measurements. We want to figure out the proportion of these that is made up by the number 5. So let's start off with this. Whenever you hear the word proportion, what does that mean to you? It's a ratio or a fraction, right? You're saying, hey, how many of the total, right? What percentage of the total, rather, is made up by the number 5? So if you want to figure that out, what do you have to know? How many we have total, and how many do we have total here? 12, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 numbers total. And we already said that we have 4 number 5s. So if we wanted to figure out that fraction, what do? Yep, 4 divided by 12, or 1/3, which is approximately equal to 33.3%. So therefore, the relative frequency of the number 5 is 1/3, or about 33.3%. Everybody good with relative frequency so far?
Actually, sorry, I dozed off.
That's fine. So all we're doing here is we're saying this. We're saying if we want to find the relative frequency, we want to find the proportion of all measurements that are made up by the number 5.
So you count how many times 5 is there?
That's right. We count how many times out of 5 that we get a...
Equals 4, and then where does the 12 come from?
We have 12 total numbers.
Okay.
So then therefore 4 out of the 12, or 1/3 of them, is the relative frequency. Cool. So let's do this. Let's say we wanted to find the relative frequency. Let's do one more of the number 2. So take a minute or so for yourself and see if you can calculate out the relative frequency of the number 2.
For our answers in this class, do you want to see percentages?
Great question. So the questions on the exam and on your homework are always going to be multiple choice. So whatever format the answer choice is in, that's how you're going to be recording you're going to pick out which answer is the correct one. So that means that you have to be comfortable with converting a fraction to a decimal place to a percentage, right? Knowing that all of those are equal. So either here, a fraction, or a decimal place, or a percentage, knowing that all three of those are correct. And then whatever format the answer choice is in, that's just what it is. All right. If you wanted to calculate out the relative frequency of the number 2, what do you do?
1 divided by 12.
Awesome. So we're saying the relative frequency of the number 2. There's only one number 2 that we have in our data. That's what we can get from our data frequency table. And we still have 12 total numbers, so we're going to have 1/12 and whatever fraction that comes out to be. What is that like? Yeah, that sounds right. Cool. Everybody good with relative frequency? How to calculate out relative frequency? Any questions whatsoever about that? All right, y'all. That is chapter 1. Any questions about chapter 1?
I have a question.
Yes.
So is relative frequency denoted by some kind of like symbol, or is it just going to be like, what is the relative frequency for 5?
Yeah, there's no symbol for it. So question was, in case you couldn't hear it, does the relative frequency have a symbol? Answer is the relative frequency does not have a symbol. It's always just going to be explicit, like find the relative frequency of whatever number. Good? Any other questions about this?
Pretty much the frequency table kind of gives you the answers to the relative frequency if you just plug it in correctly.
Yeah, exactly. The relative frequency table, the data frequency table is going to be really, really helpful for calculating out the relative frequency as long as you're making that table correctly.